This graph shows the function f of t equals the square root of 1 minus t squared, defined on the interval from -1 to 1. The plot compares its second-degree Taylor polynomial and its second-degree Fourier polynomial. Notice how the Taylor approximation fits well near the center, while the Fourier approximation aims for a better fit across the entire period. Taylor approximation provides a local fit near a specific point, matching the function and its derivatives at that location. In contrast, the Fourier approximation seeks a global fit, minimizing the overall difference across the entire period. To approximate a periodic function using a Fourier series, we calculate specific coefficients. These coefficients determine how much each sine and cosine term contributes to the approximation. The coefficient a0 represents the average value of the function over one period. The coefficients a sub k are found by integrating the product of the function and cosine terms over one period. Similarly, the coefficients b sub k are calculated using sine terms. Together, these coefficients form the real Fourier coefficients of the function. Let's work through an example by finding the third-degree Fourier polynomial for the function f of t equals t squared, defined on the interval from -1 to 1 and extended periodically. First, we note that the function is defined on an interval of length 2, so the period t is 2. The fundamental angular frequency, omega naught, is pi. Here, t equals 2, and omega naught, the fundamental frequency, is pi. Next, we calculate the average value a0 using the formula for Fourier coefficients. Integrating t squared from -1 to 1 gives 2/3, and dividing by 2 yields a naught equals 1/3. Now we compute the coefficients a sub k for k equals 1, 2, and 3. Since t squared is an even function, all b sub k coefficients will be 0. The formula for a sub k simplifies to this integral, which can be evaluated using integration by parts or a symbolic tool. Finally, we write the degree 3 Fourier polynomial using the computed coefficients. The resulting polynomial is a sum of the average value and the first 3 cosine terms, each multiplied by their respective coefficients.